So please always remind me to start the recording. Now, how can we prove? We will use the same proof as we had earlier proven with 5.3. We use the Laplace transform. We define this new function, u of nt. We saw there that gt plus h comes out to be this, so we take it as it is, as we have shown there. There it was also nt, here it is also nt, and that is, nt plus h is already all the same. Now we know that the probability that number of events is 0 was equal to 1 minus lambda th plus oh. This we have, because we know what was the probability of 1, and we know what was the probability of 2 or greater than 2. And the probability of 0 will be 1 minus the probability of the probability of 1, and then minus oh and minus oh, which is the probability of 1 and 2. So which, if you add 2OH, it becomes a OH, no problem. So you can write it as plus minus OH. So this is also we have studied. And this we also saw that GT plus comes out to be GT times this thing. Actually, I think I have also forgotten. We can just see the proof in the previous, then you will be able to remember. So we could see in the previous proofs, gt plus h comes out to be gt times this thing, which was e of this. So e of this is now, you can see nt is this, and probability of nt0 is this. So mean of this will be the probability of 0 times the value of 0 plus the probability of 1 times the value of 1 plus the probability of having 2 or greater than 2 events times the random variable for 2. So if you could see here, we have also done this. So if you could remember, these were the 3 probabilities, and they are also defined now. Only difference is that now it is lambda t and lambda t, rest is same. So the mean value of this function will be 0 times mean value of this will be not 0 times, but e of 0, because nth is 0, e of 0 is 1 times this thing plus u of 1, so this becomes e of minus u times this thing plus this 2 e minus u 2 times this thing, but e minus 2u times this is o of h. So same all of this thing, okay, it could be written like this. Similarly, you can also write it like this. This we have already seen. So we will just write it like this, but the only change will be lambda will be now lambda t. So now please check. So you can see here, gt is there, and 1 minus lambda t h, only lambda has changed to lambda t. And again, you have e minus u lambda t, and this is o of h. So everything is same, only lambda is changed to lambda t. This comes
सर
for 2 and a
सर
portion of 1. This comes for 1 and this comes for 0. All their OH, they all combine to give you 1 OH. हाँ जी, any question?
जी सर इसमें ये जो भी प्रूव करवा रहे हैं सर, इसमें वो तीनों की वैल्यू लैम्डा टी को तीन वैल्यूज पुट करता है 0 1 2 और फिर उनको ऐड करता है। सर ऐड करने के बाद जो जिसको वो 0 पुट कर रहा है वो तो आ जाएगी विदाउट ई, और जिसमें 1 और 2 पुट कर रहा है उसकी ई रेस टू माइनस यू लैम्डा टी एच प्लस ओ ऑफ एच आ जाएगी। सर इसमें एक क्वेश्चन था कि जब 2 की वैल्यू पुट करता है तो उसमें भी ओ एफ एच है, लेकिन जब इसको आपने अभी सॉल्व किया यानी कि इक्वेशन जो नजर आ रही, तो सर इसमें सिंगल ओ एफ एच आ रहा है, तो सर वो जो 2 का ओ एफ एच है वो कहाँ गया? मतलब दो
तो ना
ओ
आप,
एफ एच
हाँ,
बनते
2
हैं।
OF H है ना, तो देखिए ना OF H इंटू ई माइनस यू किसके बराबर होगा? वो भी OH होगा। ये
जी
तो
बिल्कुल वो
प्रॉपर्टी
भी
हम
होगा,
कर,
तो दोनों को सम कर दिया ना
और दो
दोनों
एच
को।
को सम करें वो भी OH। कोई भी लीनियर कॉम्बिनेशन ऑफ OH हमेशा OH होता है, ये याद रखें आप। देखें जब हम शुरू
जी
में पढ़ रहे
ठीक
थे
है।
ना, ये मैंने सीधे OH का आज सवाल पूछा सुबह, मतलब फॉरन क्लास स्टार्ट होते ही, ताकि चूंकि अब इसकी मैथ में है ही OH, तो ये सारा कुछ रिजल्ट का मैंने ये रिजल्ट बन गया आपका।
ठीक है सर।
कोई लीनियर कॉम्बिनेशन OH की जितनी मर्जी हो जाए वो OH बना दे।
जी सर ठीक है।
और यहाँ पे देखिए ना, यही है ना, 1 माइनस सारा कुछ करने के बाद ये बचता है ना, सारा कुछ
जी
OH हो
सर।
जाता है, 1 माइनस लैम्डा एच ई माइनस यू, ये बचना है। ये चीज हमने यहाँ पे लिख दी।
जी सर।
1 माइनस लेमडा एच ई एच लेमडा एच ओ एच, ये वही चीज़ हमने लिखी है, बस लेमडा की जगह
जी
लेमडा
सर।
टी आ गया। तो इसके बाद वही स्टेप है कि जी टी को यहाँ ले जाएं, जी टी 1 से मल्टीप्लाई होगा, जी टी यहाँ हो जाएगा, बाकी सारी टर्म्स आपको यहाँ लिखें। अब आप देखें, अब आपने जानबूझ के डिवाइड किया, यू हैव डिवाइडेड बाय h, सो यू नो दिस बिकम्स अ डिफरेंशियल फार्मूला, एच एच कैंसिल, नाउ यू हैव ओ ऑफ एच डिवाइडेड बाय h, h to into 0, नाउ दिस विल गो 0। You must have two conditions. Then O of H will go 0. Only when O of H is divided by H as well as H is going to 0, then it will go 0. Otherwise not. So you get this thing. So you can take GT here. This we have done. And previously we took its integral. So we said integral of this will be GT and this thing plus C constant. You can do also like this. But here, because you know we have this type of function, so we say no. All right, we integrate. I know we get GT, but we integrate with the limits 0 to t. All right, you can integrate both the signs, this will become GT, and then the limits 0 to 0, you have to put GT will come out to the integral in the limits 0 to t, so t minus g0. And you know this will be this thing, integrate lambda t from 0 to t, so you will get this thing. G of 0 is 0 because exponential 0 is 0, so g of 0 is 1, sorry, g of 0 is 1 because exponential of 0 is 1. This becomes 1. This we know is the definition of empty for the non-homogeneous or the non-stationary Poisson process. This is empty. This comes out empty u1 gt. So this is the Laplace transform, which is the Laplace transform of a Poisson function of a mean empty. This means that this non-homogeneous Poisson process gives me a Poisson's random variable with a mean of empty, yes, with a mean of empty, yes. Previously, you know, it was giving us a mean of lambda t. Now it is giving me a mean of lambda times t, but now it is giving me a mean of empty. You can see it also makes logical sense. There it was actually lambda just because lambda was constant, lambda comes out lambda into t. Here, you know, it is empty because empty is integral of lambda t, because lambda is not constant, it is changing, so you have to integrate, and that is why you get empty. So in this sequence, so in any other interval ns will be an interval which will start from s and go up to s plus t. The counting process will again be a non-stationary Poisson process. The intensity function will be again, you know, you can write it as lambda s because it's now starting from, it's not starting from 0 to t, it's starting from s to s plus t. So you can name this as lambda st, and again it is a function of t, and its intensity function can be written as lambda into s plus t, because it was starting from s, previously it was starting from t, starting from 0, so that is why it was lambda 0 plus t. Now it is s, that is why it is lambda s plus t. So the process nst, which starts from t and ends at s, it is not starting from 0 and ending at t, it's starting from s and ending at s plus t. So nst is a Poisson process because its mean we just saw is actually lambda sy dy, because its mean is lambda s from 0 to t, but we know it is actually going from s to s plus t, so you have change of variables to make it s to s plus t. So this is lambda sy dy, but we know that lambda sy will be equal to lambda s plus y, as lambda st is lambda s plus t, so lambda sy is equal to lambda s plus y. Now this becomes normal s, lambda s plus y dy, but we have to change the limits. So we change the variable to x. So s plus y is equal to x. Firstly, you know y was 0, so x starts from s, and then y goes to t, so x goes to s plus t. So now you have the same definition going from s to s plus t. Interval was from s to s plus t, lambda x dx, and this is the mean. The mean also shifts as your starting time shifts. The mean shifts, interval will be t, whatever that interval is there, and that interval will give you the value of the mean of this non-homogeneous, non-stationary Poisson's process. Another thing is that this sum, we have seen as a Poisson distribution as a mean. This is again the concept of the Poisson limit of the sum of the independent Bernoulli random variables. This we have seen it previously. We are now seeing it again because we saw that Bernoulli random variables can be approximated to a Poisson random variable when the two parameters of the Bernoulli random variable, that is n and p, where n is the number of tries tend towards infinity, and p, which is the success probability of success, tends towards a small number. So np tends towards the uh, the parameter of the Poisson random variable, which is lambda. So np was equal to lambda. This was our approximation. Let us again try to apply this approximation here. तो हमने असल में 10 मिनट लेट से स्टार्ट किया, इसलिए 10 मिनट बाद रिकॉर्डिंग ख़त्म होगी. सो वी स्टिल हैव 10 मिनट्स. नहीं, वो तो फिर 5:40 पे ख़त्म हो रही. That's the time, because not the recording time, it is actually the time for the Zoom. So after 9 minutes we finish, and I will again start the meeting as I've done previously. All right. Coming back to the lecture. All right. So trying to connect Poisson with Bernoulli. So we divide this interval from s to s plus t into n subintervals of length t over n. Same thing we have done before. Length is, t. From s to s plus t, the length is t. I divide t into n and I will tend n towards infinity. So intervals will become very, very small, and size of interval will become very, very small, and number of intervals n will tend towards infinity. So we can just map that number of tries turns towards infinity, and the success falling in an event falling in a subinterval that is tending towards a small number. So my interval I will be one small interval. You can just say this interval is of length t over n, because this interval starts from I minus 1 t over n and ends at I t over n. This means this is one ith one integer below. If I is 4, this will be I3. So you can see that interval size is t over n, and you can just denote it like this. And intervals are going from I to n. So for every ith interval, it starts from its I minus 1 to I, as I goes from 0 to n. So first interval will start from 0 to 1, second will start from 1 to 2, and so on and so forth. And ni is the number of events in that interval. So number of events will be the number of events that have occurred by I minus the number of events that have occurred by I minus 1, and you can subtract them to get the number of events that have occurred in the ith interval. So what is the probability that the number of events are equal to 2 or greater than 2? So I can say that this is the probability of the union of all the number of events equal to 2 and greater than 2. All right, you can very well write this. And we know that this probability will always be less than or equal to the probability of the sums of the individuals. All right, so this is also a fundamental probability theorem. The probability of the union is always less than the probability of the individuals. So this is very well true, because you can see that it has a probability of n greater than 4. It will include probability of n is equal to 2 plus probability of n is equal to 3 plus 4, 5, 6 plus going up to infinity. And there might be some common values. For example, but here, all of them are joined into one set. That is why this is the famous rule: the probability of the union always less than the probability of the individuals. Now you can see here that what is probability of any number greater than 2, and we have just seen it is basically big O of h, big O of h. Well, small O of h, I'm sorry, small O of h. Now what is h here? You can see h here, the interval is of t over n size. Every interval is t over n. This will be O t over n. But that over t over n will be the probability of 1, and there are n events, all have O t over n, so total will be n into O t over n. All right. Now, O t over n, and we know that n is tending towards infinity, so I can write this as, I take n here, I multiply and divide by t. So you can see big O of h divided by h as h tends towards 0, because t over n tending towards 0. T is just a constant, can come out, this becomes O of this. This becomes the definition of O of divided by its variable, this tends towards 0. So overall it tends towards 0. Please make sure that you understand the definition of small o. So this means that there is almost no chance that number of events in these small intervals will go 2 or greater than 2. So the chances that if in any interval an event occurs, it will be 1. So the count, as we have seen also previously, the same thing is repeated here. So the number of events will be actually equal to the number of subintervals in which an event occurs. So number of events is equal to the number of subintervals in which the events occur. Now, the probability of an event in a subinterval I is this thing. You can see this is the probability that one event occurs in an interval I. That you could see it was actually equal to lambda t into h plus O of h. This is your h, this is your interval, and lambda t is other than h. This was thing other than h. All right. S plus I t over n, या तो I minus 1 था या यही था. All right. So let's see, either you have t plus h and the rest was t. All right, so you can see that this is your T and this is your H. So O of H, and this is your lambda of T. So number of events occurring is lambda T H O H, and I know that my H interval is T over N, and my T here is S plus I T over N. So S plus I T over N and this is S plus I T over N minus T over N. You can see this is your O plus H and this is your minus, like here you have T plus H and T. One should be T plus H and other should be T. So you can see here that this will be your T plus H and this will be your T. So if I add T plus N, this will come out to be this thing. This was your T plus H, this was your T. So this will be your alpha T plus H, this will be H, and this will be O of T. इसने आई थिंक थोड़ी सी गलती कर दी है, असल में यहाँ पे ना माइनस आना चाहिए था, इसको आप करेक्ट कर लें। समझ आया कि यहाँ पे माइनस क्यों आना था? अरे मैंने कहा चलो चल जाए काम, अगर वो चलता नहीं है ना, गलत डेफिनेशन हो जाती है। चूँकि यहाँ होना चाहिए था लैम्डा ऑफ टी और ये था एच और ये था बिग स्मॉल ओ ऑफ एच। जो आपके इंटरवल्स हैं वो हैं टी प्लस एच और एच। सो टी तो आपका आई माइनस के साथ था, माइनस के साथ, या जिसको आप टी प्लस एच मेरा ख्याल से ये बेहतर है कि ये डाल दें, थोड़ी सी इससे गलती भी हो जाती कभी कभी, वैसे इतना फर्क तो नहीं पड़ता कैलकुलेशन के लिहाज से।
सर फिर नेक्स्ट स्टेप भी कंफ्यूज करेंगे जिसमें एस प्लस आई टी और एन लिखा हुआ है वो वाले।